In this video, we are going to go from the general equation of a circle to the standard equation of a circle. So let's go ahead and write those formulas out again so that we can review what they look like. So the general equation of a circle is ax squared plus by squared plus cx plus dy plus e equals 0. And we want to convert that back to our standard equation, which is x minus h squared plus y minus k squared equals r squared. Because this form here, the standard form, is a lot easier to graph from. It tells us our center, it gives us our radius, so it's a very useful form of this equation. So let's go ahead and try an example. So let's convert back the general equation, x squared plus y squared minus 10x plus 12y plus 52 equals 0. So the first thing I want to do to solve one of these equations is to move my constant, which is my number, over to the right side of my equation. At the same time, I'm going to put my x terms, so x squared minus 10x, and my y terms together. And I'm going to leave some space because the technique we're going to use to do this is called completing the square. So I'm going to start with, let's go with my x terms. So x squared minus 10x plus, I'm going to leave a space, then I'm going to put my y terms, y squared plus 12y, and I'm going to leave a space, and I'm moving that over to the other side, this 52, so I'm going to subtract 52 from both sides. So that equals negative 52. Now when we complete the square, what we're trying to do is get a quadratic expression here that will result in a factor that's a perfect square. So the way we do this every time is what we do is we say half and square. So I'm going to take my b term, which is this negative 10, and I'm going to divide it by 2, which gives me negative 5. When I square that term, I get 25. Sorry about that. Where my stuff went? There it goes. I think I'm leaning on the page button. So that equals 25. So I'm going to add 25 to the left side, which means I'm going to add 25 to the right side. Now the reason we like to do that is because if we factor this expression, x squared minus 10x plus 25, we get a factor that's a perfect square. So when I factor that, it's going to be x minus 5 squared. And if you don't believe me, go ahead and write out these binomials side by side and multiply them out, and you will find that you get x squared minus 10x plus 25. So now it's starting to look more like the standard equation of our circle. I'm going to do the same thing to my y terms. So I'm going to take my b term 12 and divide it by 2, and I get 6. 6 squared equals 36. So in order to make this a perfect square when I factor it, I'm going to add 36 to the left side, and I can't just add 36 to one side without adding 36 to the other. Now when I go ahead and I factor the y expression over here, I'm going to get y plus 6 squared. So you may have noticed that term we used, the b term, when we took half of it, that gave us the number that we want to use in our factor. The same over here. My negative 5 became my negative 5 down here. So that's a shortcut method for getting our factors down here. And then on the right side, we still have to add all these numbers. So I'm just going to pull these into my calculator real quick. Negative 52 plus 25 plus 36 equals 9. So now we have the standard, I was right the first time. We have the standard equation of the circle. And from that we can find some information. So first of all, our center. So our center is going to be 5, negative 6, and our radius is going to be the square root of 9, or 3.